Hello, everyone. I'm very glad to have this opportunity to introduce my work. My name is Lei Gao. I come from the Tsinghua University of China. Today, the topic of my presentation is from 2D SEM to 3D SEM imaging. Before my talk, for the record, I left Westlake University at the end of 2022, and all the work I'm talking about today was completed at Westlake University's microscopy core facility between 2020 and 2023. In my work, I'm often asked, what is different between 2D SEM and 3D SEM? Now, let's look at two pictures. The upper one is reconstructed with many 2D images. So we observe the imaging from any angle. The lower one looks very three-dimensional. However, it's only a 2D image. In our world, 2D objects are defined as having length and breadth, but no depth. And 3D objects are defined as having or seeming to have 3 dimensions. In other words, in 2D imaging, the x-axis represents the width, and the y-axis represents depth, whereas in 3D, height is represented by the z-axis. This slide shows some 2D images by the field emission scanning electron microscope. Some of the pictures are painted in false color. Of course, 3D images can also be obtained using SEM. If we take many images, just like this, of a sample by rotating with a single angle, we can reconstruct the data and obtain 3D images. This shows the 3D image of a fruit fly. We rotate the stage with a small angle and gather the data to make a 3D image. But this pixel size is not enough. If you use the X-ray microscope, I think the data is better, making the work simpler, and the result with the X-ray microscope is better. If you don't need enough resolution, I think X-ray microscope is better. And the SEM cannot see the inside of the sample. Next, I will introduce the methods of gathering 3D images of SPF SEM and FIB SEM. SPF SEM repeats the sample cutting with a diamond knife, and the observation of a back-scattered electron image of new sample surface in the specimen chamber. The FIB SEM repeats the sample splintering by a focus L beam, and the observation of back-scattered electron image of the new sample surface in the specimen chamber. Now, let's look at a few cases of SPF SEM. First, I will talk about the African ant. This ant has an has a think cell, and it's difficult to obtain a satisfactory structure by ordinary sample preparation methods. I improved the sample preparation method and got a good data using the cerebral SEM. After killing the ant with carbon dioxide, with preserve the structure, I cut the hand into 8 parts, just like cutting a watermelon. I put the sample into chemical fixation in a vacuum, which increase the infiltration of the chemical fixation at room temperature for 1 hour, and then overnight at 4 degrees, and process it using the ROTO method. This method produce good data. Next, I gather the image. This movie shows the reconstruction of tunnels through the ant's brain, and the ant's had glands, and we accidentally cut a hair sensor, but it was not a complete sensor. We wanted to obtain the 3D structure of a complete sensor at the EM level. So we use the X-ray microscope to locate the sensors, and the sample typically processed for serial block face imaging can be scanned with the X-ray microscope. The X-ray data says there was used for reference to direct subsequent trimming. A semi-thin section was cut and compared with a virtual X-ray section to align the resin block with the X-ray data site. Then we use the HPF. Of C. elegans. HPF is a physical fixation. Why we use the physical fixation and did not use the chemical fixation? Because the C. elegans using chemical fixation cannot get a better structure. So we use the HPF. I did this case for one year. I used the HPF, ROTO, cutting, and imaging by cerebral. C. elegans always culture with E. coli. When we prepared sample, we used the sulfur disc instead to type B carrier, because it has good thermal conductivity. It's transparent, and when we cover it, we can see if there are bubbles in it, if the C. elegans loose when we close the carrier. The C. elegans loose with the liquid. After freeze substitution, we made the sample to room temperature and did ROTO. All the reasons are dissolved with ecotone, and if it is not good to dissolve, we use the central fields, and infiltration and embedding with EPON. In this case, we didn't use the hexadecane because I think we use the BSA 20% BSA because we think the C. elegans didn't like the hexadecane. When I used the OTO, the sample was too black and I couldn't find the target. So I used the X-ray microscope to localize the sample. Then I chose the E. coli around the C. elegans, just like this, because C. elegans can protect the E. coli can protect the C. elegans and increase the sample's electron conductivity. After trimming the sample, I use the 3-wheel to connect the data. And this slide shows the C. elegans local structure. You can see this structure is better than chemical fixation. And in this, although we use the ROTO, but there is no lead, no staining lead. The researcher thinks the contract of the imaging is not good if we didn't use the lead. However, lead is water soluble. So we learn from Tin Kei Chung's method of rehydration stand by stand. Then we can strain the lead and dehydration again. Slides show I will introduce some tools help me prepare the sample. For the 3-wheel, training the sample is very important. The key step is to put the sample on the top of the pin, just like this. People always lose the sample when they cut it and glue it. So I cut the pipette, put it onto the top of the pin, put the sample in it, added the resin, and lastly, the samples were embedded in fresh resin at 60 degrees for 2 days. And we can trim the sample on the pin. I also use another homemade tools, just like this. Yeah. This is a low coding pin. I use the acupuncture needle, whose tip diameter is about 1 to 3 micrometer to locate the line on the top of the resin. I use this on the top of this resin. And after this, I cover a parafilm. I cover a parafilm and trim the excess resin. This is the when I trimming after trimming the sample. This sample left. I put it into the 3-wheel. Sometimes I collect the data by 3-wheel with some sample prepared without the OTO. This slide shows it. We also gather better data. Next, I will introduce the imaging of 3D SEM by FIB. I test the sample by cross-bin 5 50 and PFIB. They use different L-bin, different working distance, and different bin current cutting the sample. One stage is moved and the other isn't. Slides shows the data collected by cross-bin 550. The area is 80 to 80 micrometer. We cut the spinal cord of the right. We use the chemical fixation, ROTO, and the resin. We use the docupen. The reconstruction software, we use the Dragonfly. This slide shows the data collected by PFIB. The area is 160 to 100 by 160 micrometer. I think both of the machines are as good as each other. This slide is imaging Aspergillus fumigatus by HPF and FIB. It's a conditional pathogenic fungi. Spores are abundant in the environment and can cause disease when the body's immune systems is low. It's mainly cause invasive pulmonary Aspergillus disease. Use the OTO, but no lead staining. As you know, the JAS FIB has a fixed working distance, so the image has a worse contrast. I change the ESB gray voltage from 80 to 0, so it can receive two channels of signal. One is a back scattering signal, and the other is secondary scattering signal. And I use the OTO, but no, I also use the FIB to cutting the cells for the sample preparation. I use the HPF. First, I coding the sulfur disc and by polarizing and culture the cell on the sulfur disc and make the sulfur disc to HPF. Yeah. This movie show the culture cells. In these slides, I'd like to talk about some methods I did with correlative light and electron microscopy. I think if you want to gather good data from LM and EM, you should get a high resolution light imaging first. I think using a super resolution light microscope is better, and you need serial images by the FIB. It's an easier match than other methods. In the end, I would like to make the following acknowledgement, in particular Yalin Wang and Alice Liang, who has been a great support to me in my work, and also to the team at Westlake University. Thank you for listening. If you have any question, I'd be happy to answer them.
Okay, Kedar, you have some question in chat. Do you want to start?
Well, I mean, if we only have 3 minutes, I don't know if we can do this in detail, but I just found the use of the thin needles to orient your serial block face small samples on the pin quite interesting, but I didn't quite understand how it was done. So if Lei can maybe spend a minute describing how exactly she did that, that would be very useful. But if it takes more than 2 minutes, we can do it later. So how did the acupuncture needle help with orienting the samples for single block face?
This no. Oh, sorry.
Great images, by the way. This is really cool stuff. Yeah.
Yeah. I use the acupuncture needle because it's so thin. Yeah. The tap diameter is little.
So did you put did you use epoxy to put the sample right on the top of the needle? Is that what you did?
Yeah.
Oh, okay.
Yeah. I think I'm not here clearly. Yeah.
Oh, that's okay. We can do this later, but yeah, I was just curious.
Yeah.
I haven't used them, and I'd be very interested to learn how to use it. Thank you.
Yeah. Okay. I think Lei, you use the needle to mark the area, right? Instead of using razor blade. Is that what you do? Because you told me
it's
that
better than
the razor blades because it's thinner. Is that right?
Yeah.
Okay.
Yes.
Yeah. All right. Alice, you have a question? Go ahead.
Yes, the image is really nice, Lei. One question is when you do the cell culture on the sapphire disc, and you said you use a polylysine to coat the sapphire disc and leave in at 4 degrees, let it dry. But I just want to know why you use 4 degrees, because in general, when we do the polylysine coating, we always put like either 37 degrees or room temperature. What's the advantage of putting into 4 degrees?
Oh yeah. Sometimes I always put it before my experiment. Yeah. I prepare it before for I prepare the sapphire disc, and if I use it, I put it out.
It means you can just prepare and leave in 4 degrees, and it can be let it dry whatever time. So when you need it, you just take them out.
Yes.
Okay, but another thing is when you put it into 4 degrees, as you are going to put it into culture later, basically you need to also either use UV to make sure it's not anything growing, right? That's before you culture. Yeah. Okay.
Always use the UV. Yeah.
Thank you.
I have a question, Lei. So you showed some of the images of sample just prepared regularly without using ROTO, right? Reduce the heavy metal staining method. I mean, in your experience, is there some specific sample really need this heavy contrast, or some certain sample that can go without special heavy metal staining?
Yes. Some people think not using staining, not use the staining lead is better. But in this, the researcher didn't think the contrast is better. So when we read the picture, we used his preparation, his method, and we rehydrate the sample to the temperature, room temperature, and make the water in the sample, make the water in sample again, and dehydration again, and make staining lead.